displacement current between the plates of the capacitor. Epsilon naught d by dt of phi of v, where phi of v is the electric flux between the plates. Where electric flux equals to EA, intensity of electric field and the area through which the flux passing. A is nothing but area of the plate, each plate can be taken. Flux between the two plates here. Phi equals to E into A, equals to epsilon naught d EA by dt. Here V equals to E equals to intensity of electric field. This can be taken as epsilon naught A. A is the constant. E varies with time t. dE by dt. This is the required formula. Here epsilon naught equals to 8.85 into 10 to the power of minus 12 coulomb square, Newton per minus 1, meter per minus 2. A is the area of the plate, 10 to the power of minus 4 meter square. dE by dt, rate of change of intensity of electric field, 3 into 10 to the power of 16. dE by dt equals to 3 into 10 to the power of 6. Volt per meter second per minus 1. So after substituting all values here, ID value will come. ID equals to 2.7 into 10 to the power of minus 9 ampere. Displacement current is the current between the two plates of the capacitor. Here phi E, intense electric flux between the plates of the capacitor. Phi E equals to E for electric field, flux due to electric field. E, intensity of electric field, A, area through which the flux passing. Here A equals to area of the each plate. Another problem. Displacement current. Between the plates of a capacitor. ID equals to epsilon naught d by dt of phi of E, where phi of E is the electric flux between the plates. So phi of E equals to E into A, E equals to V by D into A. Since intensity of electric field E equals to potential difference between the plates and distance between the plates. Intensity of electric field between the plates equals to potential difference between the plates and distance of separation between the plates. So ID equals to epsilon naught d by dt of V by D into A. That equals to epsilon naught A V by D into T. V by T can be taken. V is the potential difference between the plates. You know the epsilon naught value. Epsilon naught equals to 8.85 into 10 to the power of minus 12 SI units. V equals to 400 volts given in the problem. Area equals to 60 centimeters square, 60 into 10 to the power of minus 4 meters square. Time 10 to the power of minus 6 seconds. Distance of separation d equals to 2 in 10 to the power of 3 meter. So to all values, id will come, id displacement current id equals to will come 1.062 into 10 to the power of minus 2 ampere will come answer. Taken by the EM wave to cover distance L is T equals to length by distance by velocity. Okay na? Next one, energy contained in the space of length L is U equals to P into T, where P is the power of source of EM wave. U equals to P into T. After finding the T, P by substituting the P and T values, energy contained in the space of the length L can be calculated. Next one, intensity of light. Intensity of laser beam or EM wave. I equals to half epsilon naught E naught square into C. C is the velocity of light. C is speed of the EM wave. By substituting the E value, I value if given, E naught can be calculated. From this equation, E naught is the intensity of electric field. E naught equals to root of 2I by epsilon naught into C. By substituting the all values, you can find the amplitude of electric field, energy contained in the space of length L, time taken by the EM wave to cover the distance L. Here L equals to 90 centimeter, 90 in 10 to the power of minus 2. Well, the speed of the light EM wave equals to 3 in 10 to the power of 8 meter per second. Here power of the source is given as power equals to 6 into 10 to the power of 3 watt. 6 in 10 to the power of minus 3 watt power of the tap. T can be calculated now. T value 3 in 10 to the power of minus 9 seconds will come. T value will come 3 in 10 to the power of minus 9 seconds will come. Up to the U and P value. U will come energy contained in the space of length L will come energy equals to 18 into 10 to the power of minus 12 joule will come. So afterwards, next the third bit, this is the first bit, this is the second bit, this is the third bit. By substituting the I value, epsilon naught value, C value, intensity of a liquid can be measured. Here intensity of the beam is given as, I is given as 17.7 SI unit. C is the known value, epsilon is the known value. What is epsilon naught? Epsilon naught equals to 8.85 into 10 to the power of minus 12 SI unit. Substitute all values, find the E naught. E naught will come, by calculating the E naught will come 2 by 3 into 10 to the power of 2 volt per meter will come. E by 3 value, E naught value, 2 by 3 10 to the power of 2 volt per meter will come. Epsilon naught value, C is the real value, I is the 17.7 SI unit, 17.17 SI unit. So totally you can calculate the all value, E naught value. Displacement current between the plates of a capacitor ID equals to epsilon naught d by dt of phi e. Phi is the electric flux between the plates. Phi is the electric flux between the plates. Here phi e is electric flux between the plates. That equals to E into area. E equals to V by D into A. V is the potential difference between the two plates. D is the distance between the two plates. V equals to Q by C. This will be equals to V equals to Q by C into A by D. Q by C into A by D. That equals to Q by epsilon naught A by D into A by D. D gets cancel. Q by epsilon naught. So ID equals to epsilon naught D by dt into Q by epsilon naught. It is equals to dq by dt. Q by t is given now. Q by t equals to 1.8 into 10 to the power of minus 8 coulombs per second. 1.8 into 10 to the power of minus 8 coulombs per second is the answer. Here important formula. Q equals to C equals to epsilon naught A by D. Here important you have to remember. It is the flux E. It is the flux E. C equals to capacity of the parallel-plate capacitor. C equals to epsilon naught A by D. A is the area of the plate. D is the distance between the two plates. Next one. Potential difference between the plates equals to Q by C. Q by C. Intensity of electric field between the plates equals to V by D. These are very important substitute here. Answer: displacement current between the plates in terms of charge, dq increasing charge equal 1.8 into 10 to the power of minus 8 coulombs per second. If an electromagnetic wave is reflected by a denser medium, its phase is changed by pi or 180 degrees. Initial EM wave is given by E equals to E naught I cap into cos of kz minus omega t. This equation, this EM wave propagates along the positive z axis. After reflection, reflected EM wave is given by ER equals to E naught into minus I cap cos of cos k into minus z minus omega t plus phi. Minus E naught cos of phi minus of kz plus omega t. It is equals to minus E naught I cap minus cos kz plus omega t. It is equals to E naught I cap cos kz plus omega t. This equation represent a reflected electromagnetic wave. This equation incident electromagnetic wave on the surface. Here important I value, I becomes I minus I cap, z becomes minus z cap. So phase change pi e should be there. Cos of phi minus theta equals to minus cos theta. Minus I cap minus cos theta both will cancel. E naught I cap cos kz plus omega t represents the wave propagates along A to Z axis. Intensity of EM wave. I equals to 1 by 2 epsilon naught E naught square into C. E naught is amplitude of electric field C is speed of EM wave. From the above equation, E naught equals to root of 2I by epsilon naught C. But intensity I equals to P by A. E naught equals to root P by epsilon naught CA. E naught proportional to root P. E naught 2 by E naught 1 equals to E naught 2 by E naught 1 equals to root of P2 by P1. P2 equals to 50 watt, P1 equals to 100 watt, E01 equals to E. So E02 equals to E by root 2 is the answer. Intensity of EM wave I equals to P by A, where P is power of source of EM wave. A is the area on which the wave falls. On which the wave falls. But P equals to U by T. Then I equals to U by AT. U is energy of EM wave. So U equals to IAT. if EM wave is incident on non-reflecting surface, force acting on surface F equals to small p by t, where small p equals to u by c is momentum delivered to surface. So F equals to U means IAT by C. Radiation pressure on surface PR equals to F by A. F equals to IA into T also is there. IA by C. Radiation pressure equals to IA by C by A. IA by C by A equals to I by C. Radiation pressure equal to F by A. F equal to IA by C. F equal to IA by C by A. A gets cancelled. I by C. C is the speed of the light. C is speed of light, speed of wave. This is the direction of propagation of EM wave. Direction of electric field, direction of magnetic field in the EM wave. E bar cross B bar gives the direction of the propagation of the EM wave. If the direction of electric field in the EM wave is along I cap plus J cap, is along I cap plus J cap, I cap plus J cap, sorry, in the EM wave E bar is in the EM wave E bar is along I cap plus J cap, J I K cap. This is the direction of E bar. This should be direction of E bar plus B bar, propagation of EM wave. The direction of electric field is the direction of magnetic field. the direction of magnetic field should be minus I cap plus J cap. So it is the I bar plus K bar. The direction of magnetic field, it is minus K cap, minus I cap. It is the B bar direction. It is the B bar direction. So in this problem, we have to find out the direction of the magnetic field minus I cap. It is the minus I cap plus J cap. So E bar cross B bar should be direction na. Here E bar cross B bar should be along positive Z direction. So I cap plus J cap cross minus I cap plus J cap should be equal to 2K cap. So finally, according to this condition is satisfied, the direction of the B bar is along minus I cap plus J cap. Energy falling on reflecting surface per second. U equals to E. That is given as 10 joules. Linear momentum of each photon, small p equals to h by lambda. H by lambda equals to c by nu na, c by n. H n by c. P equals to E by C. E equal to h nu. Momentum of each photon. On reflection, change in momentum per second. Equals to force on surface. Change in momentum equals to final momentum minus initial momentum equals to force. It is equals to P minus of minus P by T. So force on surface to P by T. P equals to U by C na, 2E by C. 2E by C. Since T equals to 1 second. Force on surface equals to 2E by C. Force on surface equal to E by C answer. Rate of change of momentum equal to force. Here rate of P initial momentum minus or minus final momentum. Sorry, final momentum minus or minus initial momentum. Initial momentum P in one direction along negative. Both momentums are equal magnitude and opposite direction per second. 1 second. So F equals to, here T equals to, not per, T equals to 1 second. So force on surface equal to F equal to P by T. 2E by C is the answer. Substitute the all values, we can find out the C moment of F. So F will come, in this case, F will come, substitute the all values, F will come. So F equals to 2 into 10 joules. E by T equals to 10 into T is there. E by T equals to 10. E by T equals 10 joules divided by 3 in 10 to the power of 8. Answer 6.7 into 10 to the power of minus 8 newtons. This is the force formula. C by 2 E by C. C by E by T equal 10 joules. So we can substitute the all values, you can get the force on the reflection surface.